want to share with you one more tool that we've discovered that can be helpful sometimes in describing lines, their slopes, their graphs, and so forth. And these situations pop up when, say, for example, I have some arbitrary graph, some arbitrary line, and I know that there's a point on the line. I know this point for sure, and I know its slope. And then there's some other arbitrary point on that line. I don't know exactly where that point's at, but I know it has some x and y coordinate. And that makes sense. So given that as a starting to this idea, let's see what we can determine. Let's just kind of play around with some math. Let's go back and see if we can remember what the equation for the slope was. Remember the slope was equals, slope is a change in its rise over run, so x2 minus, y2 minus, can I change that into a y? y1 over x2 minus x1. That was our definition or equation of a slope. So over here, we have our x1s and y1s, and here we kind of have our x2s and y2s. Since I don't have a specific point, I'm going to insert those values. So my y2 value is just some arbitrary y minus y1. And I have some arbitrary value of x minus x1. Now I know this can be a little confusing sometimes because we're so used to seeing this equations with y2s and y1s and whatnot. And we start to omit those y2s in this particular form because it doesn't match up with a very specific point on the graph, just an arbitrary point. Anyway, if that was confusing, don't let that bother you. It will still kind of work out to where we're going. And then with practice, you're going to have this aha moment. It's going to wake you up in the middle of the night and goes, oh, okay, I get it. So let's solve this equation. Let's remove the fractions. So I'm going to multiply both sides by an x minus x1. Nope. When I said multiply both sides by that, that's what I meant. So that cancels, and I'm left with an x minus x1 times an m equals a y minus a y1. And then I'm going to rearrange that. So I'm going to have a y minus a y1 equals an m times an x minus an x1. Basically, I just rewrote the slope, the equation for slope, all in a straight line. And we call this one the point slope form or the point slope equation of a line. And this is a useful tool when we know one point and a slope. As opposed to before, we knew 2 points and no slope. Now we know 1 point and a slope. And when we have that starting information, we can use this as a way to help us get to where we might want to go.